Hi, everybody. Mr. Martinez here. I hope you're having a good day and that you enjoy your weekend. The breathing exercise for today is think about one of your favorite memories and then try to describe it to yourself, or maybe try to describe it to your friends as you see them online this week. The announcements are I encourage you to go be adventurous this week in some manner. So that doesn't necessarily mean you have to go out and be adventurous. It just means do something different. If you're used to being on your phone, if you're used to playing games all the time, like Fortnite and whatnot, then do something different. Maybe read a book or learn how to cook something. Be patient with yourself too, especially those who are used to doing something like working out or reading a book or doing this and that. uh just be patient with yourself. Okay, we're gonna do a little bit of review. Classify the solid. Remember to include the name of the base. So if you look at this one, the one on the left, you might notice how we have this hexagon right here, and it's a regular hexagon because of these tallies. Okay, so that's going to be a base of a hexagon, regular hexagon. And then notice how there's only one base. So because there's only one base, this is not a prism. This is a pyramid. Notice how they are triangles that surround the perimeter. They surround the perimeter of the hexagon. So this is going to be a right regular hexagonal pyramid. Specifically, we're okay if you say regular hexagonal pyramid. All right, this one is, it could be confusing, but this one has two triangles that are equilateral because of the tallies. And notice how there's only two of those. So that's going to give you a clue that that's not a pyramid, because a pyramid has the whole perimeter are triangles. But here, there's only two. So it's going to be a regular prism that has a regular triangular prism, I should say, that has quadrilaterals that are the lateral area. All right. Today, what we are going to be talking about are right cylinders. So I'm just going to go ahead and differentiate between both of them, just so you kind of understand what right is versus the other version of it. A right cylinder, a cylinder has this circular base, and it has this other circular base, and then it has this lateral face that's wrapped around it. So a right cylinder means that it's standing upright, so it's up and down vertical. Versus an oblique cylinder, notice how it's slanted. So that's the main difference. So here, the altitude is from one center to the other center of the bases. But here we cannot do that, because look, if we go from one center to the other center, this is more diagonal. Okay, so the height is just from one base to the other base. But we will be focusing on the right cylinder. Okay, so I want you to just take a moment and try to sketch a net for a right cylinder, a cylinder that stands upright. One way to think of this is if you take a can of soup or a can of beans. If you take off the lids, top and bottom, and then if you take off the wrapper, then it will look like this. It will look like two circles with something that looks more like a rectangle, even though this rectangle wraps around the circle. So this is going to help us find the lateral area. So let's try to think about lateral area, okay? So first we're going to think about the lateral area. By the way, Miss Saxena, shout out to her. She let me borrow this tablet that lets me sketch without using the trackpad. So hopefully that helps out a lot. Okay, so if you notice this lateral area right here, the one in green, it is a quadrilateral. So we know that a quadrilateral has, the area of it is the height and then the base. Okay, well, we also talked about how this base right here wraps around this circle. And remember, the perimeter of a circle is just the same thing as the circumference of a circle. So what we're going to do is to find the area of the rectangle or the lateral area. We're going to do base times the height, but the base is actually going to be the circumference of the circle because it wraps around the circle. So the circumference, remember, is 2 pi r, and then that's it. So the lateral area is the following: 2 times pi times r times how tall, or the altitude from one base to the other base. Okay, so that is the lateral area for a cylinder. Lateral area for a cylinder, 2 pi r. So here's radius, here's the height from one center to the other center, and then that's the lateral area. So it kind of makes sense, right? Because we know that this is just the circumference. That's just the circumference of a circle. Or in our case, that's just like the base. That would be just like the base of the rectangle. Okay? And then how tall the solid is. All right, let's go ahead and now look at the total surface area. So total surface area, you might see here that the total surface area would also include this area of the circles. So we are also going to include the area of the circle. So for the area of a circle, I'm going to put capital B. Capital B stands for the area of the circles. That's, I apologize, that is pi r squared, as you might recall it. So pi r squared. Okay, but because there are two, remember, two circles, two bases, 1, 2, we're going to multiply this area by 2. All right, so altogether, the total surface area is the area of both bases, so 2 times the area of one base, so 2 circular areas, plus the lateral area. All right, let's go ahead and try an example. You ready? Let's find the lateral area of the cylinder. So we are going to use the, what am I trying to say? We are going to use the lateral, the net. That's what I'm trying to say. We're going to use the net of this shape. So for the net, right, this is the height. The height goes from one to the other. So I'm going to label this as H. And then I'm going to go ahead and use red. Red is going to be this right here, the base of the rectangle, right? And remember, the base of the rectangle, it wraps around the circumference of the circle. So that's going to be 2 pi r. All right, so now let's find the area, the lateral area. So I'm going to do area, I'm going to do 5, because that's the height, times 2 pi r. And 2 pi r, that's going to be 2 times pi times 3, because that's the radius right here. The radius is from the center to a point on the circumference, 3. So altogether we have 10 times 3. Let's keep it as exact. So that means that we're going to keep the pi in there. So this is 30 pi centimeters squared. Do not forget unit squared. All right, that's the lateral area. Let's do total surface area. Now, total surface area, it includes the area of the bases. Okay, so let's find the area of the base, capital B. That's pi r squared, so that's going to be 3 times 3, which is 9 pi centimeters squared. But remember, this down here is also 9 pi centimeters squared, because these two circles have the same radius. They have the same radius, so that means that the circles are congruent. So we're going to have the following. For the total surface area, it's going to be 2 times the area of the base, which is 9 pi centimeters squared. And then we're going to add this area as well. Well, we're going to add the area the lateral area. Okay, so for the lateral area, we are going to add 30 pi centimeters squared. So we're going to add it, and then we're going to see what we get. Okay, so feel free to try to do that in your head, or use the calculator. Does not really matter. All right, so 18 plus 30. So notice how this is 18 pi plus 30 pi. That's why we can add the two coefficients, which are the numbers in front. That's going to give us 48 pi centimeters squared. And that is it. That is the total surface area of this cylinder with these dimensions. Okay, here's what I want you to think about. If you have any coins, preferably quarters just because they're a little bit more bigger circles, or you can use pennies or dimes, go ahead and find them. All right, now that you found them, create a cylinder and try to come up with the formula for the volume of the cylinder. Okay, so hopefully you got quarters, you stack them up, and they created this tower, right? This cylinder. So hopefully you can figure out what is going to be the volume. Remember, volume is if you take water, or like a water bottle. If you take water and then if you pour water inside, it's the liquid that it contains. So now it's not just 2D. It's not just the area of a circle. It is in fact the area of the circle plus the area of this circle plus the area of this circle, So for the volume, we're going to take the area of one circle, right? We're going to color all this in, yada, yada, yada. And then we're going to add another congruent circle to it. And then we're going to add another congruent circle to it all the way until you get to the bottom. Okay? But those circles are still the same. They're just stacked on top of each other. So that tells us what the volume of a cylinder is. So here's the volume of a cylinder. The volume of a cylinder is pi r squared. So pi r squared, which you might remember, that's the area of one circle, times the height. So times how tall this is. And that makes sense because if you have quarters and if you're just stacking them on top of each other, then that's going to create a cylinder. Okay, so pretty straightforward. All right, so now what we're going to do is we're going to go back to this. I'm going to go ahead and duplicate this. I'm going to delete some of it because we don't really need some of it. So let's see. I'm going to delete lateral area. We don't need that. We do need the area of a base. So I'm going to go ahead and keep that there. So the area of one base we had was 9 pi centimeters squared. Okay, so now I'm going to add something to here. I'm going to put volume. So let's go ahead and put volume on here. So we're going to calculate the volume. Volume equals 2, not 2. Volume equals area of the base, right? Just one circle, which is 9 pi centimeters squared times, let me go ahead and delete this. Okay, times the height. Okay, so let's go ahead and multiply by the height. Centimeters times the height, which is 5. All right, centimeters. So notice how this is squared and that's not squared. Notice how the area is squared and the height is not squared. So that's going to give us 45. 9 times 5 is 45 pi, leave it as exact, centimeters cubed, because this squared times centimeters to the power of 1, you add the exponent, so that's how you get cubed, right? That is the volume. All right, let's see. Okay, so you might notice, maybe not, a cylinder is like a prism, except that it has bases that are circles instead of polygons. So here the bases are circles. Here the bases are polygons. So it makes sense that the formulas are the same. So a cylinder is like a prism. So notice how for a prism, the lateral area is the perimeter times the height. Well, we said the same thing. For a cylinder, the area is still the perimeter, except its circumference, right? We call the perimeter of a circle circumference. So that's going to be pi. So 2 pi r. Remember, that's the perimeter or circumference times the height. Notice how it's the exact same thing. Exact same thing. Perimeter times the height. All right, total surface area of a cylinder, it's still the same thing. 2 area of the base plus the lateral area. Boom, identical. Look at that. Volume, same exact thing. We take a quarter, area of the base or area of the quarter times the height or how many quarters we have. And that's the same thing as the prism. So that's kind of pretty neat. All right, let's go ahead and do one last one. A cylinder has a radius of 3. Okay, I'm going to just draw, like the top essentially, and a height of 7. So height, I'm going to make it dashed, it stops here. This is 7. Why not? I'll just go ahead and create the other circle. There you go. Okay. Find the lateral area, total surface area, and volume. Okay, so let's go ahead and find the lateral area. All right, lateral area is, remember, perimeter or circumference. So we want to find the circumference of the circle, which is 2 pi r, which is 6 pi units squared. And then that's it. 2 pi r times the height. So here's the perimeter portion. Here is the I apologize, ignore this right here. Here is the height, okay? So circumference times the height, and that's going to give us 42. 42 pi units squared. Okay. Let's go ahead and find now the total surface area. Total surface area. So now what we're going to do is we're going to include the area of the base. So the area of one base, I'm going to put it in blue. The area of one base is 9 pi units squared, right? 3 times 3 is 9 pi. But remember, we have to multiply this by 2 because there are 2 congruent circles. So this has 9 pi, this has 9 pi. And then we are going to add it to the lateral area. So I'm going to go ahead and add 42 pi units squared. Okay, so this is going to be 18 pi units squared plus 42 pi units squared. And then we're just going to add, right? 8 plus 2 is 10. So that's 0. 4 plus 1 plus 1, that's 6. So 60 pi units squared for TSA, total surface area, okay? So that means that the area of the lid, the area of the outside, wrapper, if you were thinking about a can, and then the bottom area as well, okay? All right, let's go ahead and find, let's see, volume. So let's go ahead and do volume in purple. So remember, volume is just, you have a quarter, you get the area of the quarter, and then you multiply by how many quarters are stacked on it, okay? So the area of the circle is, we said, 9 pi units squared. And then the height is 7 units. So that's going to be 9 times 7. Think about what that's going to be. 63 pi units cubed. Because remember, when we talk about volume, no longer are we talking about a 2D surface. We're also talking about 3D. So how tall this is, right? Because here we have another quarter, here we have another quarter, essentially until we create that cylinder that that is now 3D space. So it's now contained within that space. All right, everybody, look at that. We're done. Isn't that super fast now with this tablet? All right, have a great rest of your day, everybody.